Welcome to our lesson on projectile motion, a fundamental concept in physics describing the path of an object launched into the air. A projectile is any object in flight after being launched, like a baseball, where air resistance is often negligible. For such objects, gravity is the primary force, causing constant downward acceleration. We define our coordinate system with the x-axis horizontal and the positive y-axis pointing vertically upward. In this system, acceleration due to gravity is a gaucho GJ, meaning no horizontal acceleration. The value of g is approximately 9.8 meters per second squared, a crucial constant. Consider a projectile launched with an initial velocity v0 at an angle θ0 with respect to the horizontal x-axis. This angle θ0 is known as the angle of projection. To analyze the motion, we resolve the initial velocity into its horizontal and vertical components. The horizontal component, vx0, equals v0 cosine θ0. The vertical component, vy0, equals v0 sine θ0. These initial components are crucial for determining the projectile's velocity at any point in time. At any given time t, the horizontal velocity vx remains constant, equal to v0 cosine θ0. However, the vertical velocity vy changes due to gravity, calculated as v0 sine θ0 minus gt. Now let's determine the coordinates of the projectile over time, assuming it starts from the origin. The horizontal position, x, at time t is simply the horizontal velocity multiplied by time, x traverse t. The vertical position, y, is more complex, accounting for initial vertical velocity and gravitational acceleration. It's given by y taprachek in t minus 1/2 g squared. These two equations for x and y describe the projectile's position at any moment. Finally, we can derive the trajectory equation, which describes the actual path of the projectile. By eliminating time a from our x and y position equations, we get a single equation relating y to x. First, we solve the x equation for t, which gives us t dot x. Substituting this expression for t into the y equation yields the trajectory. The trajectory equation is y φ sau x minus j times x squared, all divided by 2 times v0 cosine θ0 squared. This parabolic equation precisely describes the path a projectile follows under gravity. Understanding these equations allows us to predict where a projectile will land, its maximum height, and its flight time. From defining a projectile to deriving its trajectory, we've covered the core principles of projectile motion. Keep exploring physics, and you'll discover how these concepts apply to countless real-world scenarios.